Hello. So in this lecture, we are going to start chapter 12 about stack. And stack is a new data structure that we are going to learn. So in this chapter, we are going to cover what is a stack and the implementation of a stack, a capacity bounded stack first, okay, using an array. And then we are going to discuss the implementation of a capacity unbounded stack using an array, okay. And so we are going to, when we discuss the capacity unbounded stack using array for the implementation, we are going to resize the array, okay, to mimic the unbounded capacity. It cannot be really unbounded, okay, due to the memory restriction, okay. And then we are going to see how we use stack to do base n conversion for any integer, okay? And then we are going to discuss the implementation of iterable and iterator interfaces on a stack. And then we are going to move to the Java collections stack discussion, okay? And lastly, in this chapter, we are going to discuss two stack-related application. One is about infix to postfix conversion and the evaluation of postfix expression. The second is going to be about solving the 8-queen puzzle using stack. Okay, so the first section is about stack concept. So what is a stack? Okay, and stack is a data structure, so abstract data structure, and it's a linear one. Okay, it's used for an ordered collection of items. Okay. And the storage for this ordered collection of items has some restriction. So it can only be accessed at one end. And that one end is the top of the stack. Okay, so be careful. Only at one end. Okay, so that's the top of the stack. And so like this diagram shows. Okay, so it shows a stack. Okay, kind of its stack is an abstract data structure. Okay, so this going to be so at the very bottom we see. So basically, this is the first item that's being stored. And then the second item stored, the third item stored. And at the very top is the newest item to be stored in this data structure. Okay. So for any data structure, it's allow you to add a new item and also allow us to remove an existing item. And for stack, when we add, we can only add at the top. Okay, so add at top. And we call this operation push in stack. Okay, and because for stack, you can only access at one end. So when you want to remove an existing line, you can only remove also at top. You cannot remove other item if there's top item on top of that. Okay, so you need to remove all the item on top of that. Then you remove the item that you want to remove. So remove at top in stack, we also call it pop. Okay, but of course, if you wanted to remove, there must at least one item, okay, at the stack, okay. So basically, we can see for stack, the first item you add will be at the bottom if we view it, okay, like a container like this, okay. So the first item will be at the top, and then the second item you add will be second last, and the third. So the last item you add will be at the top, is it? But the last item you add at the top will be the first item out, is it? So for stack, we see it is a LIFO data structure. So what is LIFO? That means it's last in and the first out. So it has this specific feature, okay, for stack, last in, first out. So keep this in mind, LIFO. So LIFO is for stack, last in, first out, only has one item, only has one end can be accessed, it's at the top. Okay, so that's stack. Okay, so we just learned the concept of stack, and we know it has a feature of LIFO, last in, first out. Okay, only access at one end, the top. And if you recall previously, when we discuss like classes, arrays, we also mentioned a memory called the stack memory, okay, or Java virtual machine memory, or it also called runtime stack. And there is another concept called heap, if you recall. Is it? Yeah. And so this runtime stack or stack memory is some special reserved memory, okay? And later we will see why we call it a stack memory, okay? Because it has a last in, first out feature, okay? So what does a stack memory store, okay? So it says whenever a method is called, including the main method, okay? So Java will create some frame, we call it a stack frame, to store all of the method-related information, okay, like a parameter, local variable, the method return address, and some other temporary storage. So anyway, we also call it an activation record, okay? So anyways, some structure, okay, used to store all the information related with method, okay? So whenever method is invoked, then the method will be pushed to the stack memory, to the top of the stack memory, okay? And so when the method finish execution, then it will be popped from the stack memory, okay, and then be destroyed. Okay, so basically in the stack memory, that activation record related with the method, or we call it a frame, at the top of the runtime stack will always be the frame currently under execution. Okay, So the method for whichever the method is being executed in an application, then that method basically its frame is at the top of the runtime stack. So we can see, yeah, stack does have applications that even in operating system, we use the stack concept. Okay, so here it shows us the idea about the stack memory, okay, how we can call method and method call another method and method call another method, but they won't lose track. And when the method finish executing, knows to return back to the point. Is it? That's because of the runtime stack. Okay. So right now, F1. So this method is currently. So this is a currently executed method. Okay, then within that F1 method, it at some point call F2. That call F2. So when it F2 get called, and we learned that it will be pushed to the stack. So it will be pushed. So now the current executed method change it to F2, is it? Okay, then F2 method at some point to call another method F3, is it? Okay, so then F3 will be pushed to the stack. And it will be at the top. So F3 is at the top of the stack. Okay. So all of this F1, F2, F3, they are stored in the stack memory. Okay. Okay, and then F3. So here is F3. So F3 execute to the last statement, so it finishes execution. Is it after it finishes execution, it will be removed from the stack. Okay. So after it remove the stack, so that's how the program knows that it will continue its execution in at the statement that right after F3, because F2 is at the top. Okay, so that's so the frame, or we call activation record, it will keep track of this information. Okay. So then F2 executed and to the last statement finish execution, then it will be removed from the stack. Then F1 will be at the top, okay, and continue execution and finish, then F1 will also be removed. Okay, so if it's main till the last statement, then the program complete its execution, okay. And so then we can also just think about it that for the stack memory, it cannot be unlimited. Okay, so it's limited because anyway, it's some machines' memory it has a limitation, restrictions. So just think about if you have some function calling other function, and if or then it will keep calling, etc. Or if it's in a forever loop or something, then it will, at some point, this stack memory will run out of capacity. So there is no more capacity to hold the new activation record or the method frame on the stack. So then the stack overflow error will be So this arrow will be slow, okay? And if you recall previously, we also discussed Stack Overflow it under arrow, and it cannot be handled, okay? And if you recall previous, we also learned the out of memory arrow. So this arrow is caused by heap. When heap run out of capacity, okay, then it can cause out of memory error. Okay, so now we understand, okay, how the method, the new number of method get invoked, and they won't lose track of which one is running at which statement, as well as like of the local information that like local variable information, etc. Okay, that's a stack memory. Okay, and so we understand the idea of a stack. So how do we implement it? Okay, so in the second section, we implemented the first, we implement capacity bounded stack and using an array. Okay, so in this example, this stack type is an integer type stack. So this stack will store some integer number like 10, 100, -30 something, okay? It will store integer number, okay? So for this kind of stack, how do we design it, okay? So the UML diagram for our stack int class, we have two instance variable. So we have an integer, we call it top, to keep track of where the top item is. And the where we are going to use the index. Okay, and all of the items, so basically here integer is going to be stored in an array, integer array, okay. And we also have a constant, okay, we call it a capacity to remember the capacity of the stack. So those are instance variable, and we then have the two constructor. To the default one create an empty, and the explicit constructor create a stack using an array. And then we also have is empty function, and the push method to add a new item at the top, pop to remove an item at the top. Pick is to retrieve the top item. ToString is to return a string, which consists of all stack items from top to bottom, okay? And clone is return a deep copy of the stack. Okay, so that's about this stack class. Okay, we are going to implement using array. And later on, we are going to take a look at the coding and to see how we implement it. Okay. And in the third section, what we discuss is capacity unbounded stack. But this is just mimic, okay, cannot be the real unbounded, okay, unlimited capacity. That's not, it just shows that the array's capacity can change, okay, it can grow, it can also shrink. But if you know array size is fixed, so if we just use a fixed array, it will not be achievable. So what we are going to do is we are going to make our array also resizable, okay? How we do it in our code, we will see, okay? And each time if the capacity reaches the limitation, then we are going to double the current array's size. Okay, so we can to optimize the memory, so to um, to be more efficiently manage the memory, is that we can also shrink the size of the data array. If we begin removing items from the stack, okay, and the additional space is no longer needed, then we can also reduce to shrink the array, okay. And we can also do the half length because previously we double the size. So we can also do halving the length of the array. Is that if remove the top item from the stack can cause the height of the stack fall below 50% of the array capacity, then we can halve the array size. So that's about the third session we discussed. Before we move to the next session, so here's a photo about a national park. Okay, a very pretty national park. So it has some mountains. It also has the lakes, and it's in the during summer, and the lake. In July, the lake's still covered with quite a lot of snow and ice. Okay, very beautiful. Okay, and uh, in the fourth session, what we are going to discuss is about how we make the stack data structure also support the for each loop. So for each loop, if a data structure want to support, then it needed to implement the iterable interface. Okay, so we're going to take a look at how we do it. And for the fifth session in this chapter is about the stack in Java collections framework. Okay, and the stack is a generic one. So you can plug in any data type, okay? And it has constructor, empty, pop, push, and pick. It also supports search, okay? And also in the Java collections framework, the stack class also implement clonable and iterable interface. And for the sixth session, it's about some application, okay? So one of the application is postfix evaluation, okay? So postfix is also RPM, okay? So reverse Polish notation. Okay, for arithmetic operation, okay, arithmetic expression. So in this kind of expression, postfix expression, there is no parentheses, okay, no parentheses. And also operator is after number. Okay. So this is a postfix expression. So with this postfix expression, how do we evaluate it? So with postfix expression, we can evaluate, we can use stack, okay? So we are going to discuss it in more detail in our coding, okay? So this is the concept for postfix evaluation. Okay, and regarding postfix evaluation, then how do we convert the regular expression? As regular, we call it infix expression. So for infix, it support the parentheses. Okay, and we also have operator preference. Okay, and so how do we convert it from infix to postfix? Yeah, we can also use array using stack data structure. Okay, another very common application for stack is to do backtracking. Okay, backtracking. And backtracking can be used in maze, okay, and can also be used to solve some puzzle, like the 8-queen puzzle. And we also have a code example. And there's another very common application for stack is to reverse an ordered collection. Ordered collection, okay? And because you can reverse, then a very common application is about palindrome check. So palindrome check, then we can also use stack. Okay, so that's the concept for the stack. And in our next lecture, we are going to take a look at the coding part. See you.